Hello and welcome to this presentation and demonstration of a sensor board system which I've developed. Um, and to get started, first I'm going to go through the report which I created so you have a better understanding of what the board and the project does. The main idea of this project is to create a electronic board with an embedded program which will uh, sense the atmosphere in your room, and it will do certain readings such as humidity levels, temperature, if the light is on or light is off. So I will walk you through all of the stuff step by step in detail. So let's get started. And before, I want to start with the report. And this report, as you can see, the title that I've given it is the Energy Efficient Environment Sensing System. And the environment is a home environment, it's your room. And as you can see in the picture, I have connected all the board and small sensors. And I will also show you because I have a second camera, and you will get to understand everything. So here is the table of contents. I have tried to lay out all of the details in different sections. And of course, all of these files will be attached and you can download them and you can look at them. But I just want to scroll in this video and maybe talk about some of the sections which I think I should explain. So this is just the introduction, and there are 4 sensors involved. This is a BME 680 sensor, which has capability to measure 4 different kind of parameters, such as pressure, temperature, humidity, and this gas pressure. I think it has some kind of special gas sensing capabilities, such as carbon dioxide. I'm not sure, but this is a multi um, uh, functional sensor, which is quite nice. So, and then the next sensor that I have here, this is a motion sensor, SR602. And the job for this is to measure any movement in the room. And I've tried using it and it works for few feet in the room. So it works quite okay. The next sensor that we have is the microphone sensor. And this microphone is, I think, is to do with the sound level, but I couldn't get it to work. Everything was connected, there was no error, so I'm not sure why it didn't pick up any sound levels, but this is one of the sensors which I have connected. Next, we have the light sensor, and the purpose of this is to detect how much light is on. And of course, if it's daytime, you will have more light in the room, and if it's night, maybe the lights are on. So there's I will talk about the readings and the data and what could be done, and what is the purpose is to understand that how the room is being used, how busy it is. So all of these sensors will collect the data periodically and then forward on. So this is the sensor section. Okay, so let's talk about the system architecture. Um, there are 2 main boards. One is ESP32S3 model, and it is connected, and this is a microcontroller, of course, and it is connected with 4 different sensors, which I just showed you, and the connections are going from the sensor to the ESP board, and then you can see an arrow going to Raspberry Pi, and Raspberry Pi is a Linux-based mini computer, and so it is bigger than the ESP32 in terms of capability and functionality, storage, and speed. And then what the purpose of the data is that after it's been collected, it's going to be sent off to internet, or maybe taken off in a micro SD card. But the data has to be first collected through this module here, and this module is meant to be a mobile, possibly battery operated module, or you can plug it into a USB cable. So this can be connected by a USB cable, and the connection between Raspberry Pi and ESP32 is wireless, mainly using Bluetooth, and specifically BLE, which is a Bluetooth low energy, which has come in the market in the recent times, which consumes very little power, and it's useful if you want to have something that is connected with a battery. So this will be connected either with a 5-volt USB cable or a battery. And after collecting the data, you can set the settings. I will show you the software where you can set how much time you want to wait before you collect new readings. Of course, if you're going to use, for example, temperature sensor throughout the day, of course the temperature varies between night and day, but there's no point collecting a temperature every 2 minutes, because of course the temperature is not going to change that much within few minutes. So I think the idea of the project is to collect data, little data over long periods of time, to understand and analyze how the room has been exposed to, what conditions the room is exposed to. And from here the connection goes via Bluetooth, as I said, and it is saved in Raspberry Pi. And for now the data will be saved over here, and this arrow is the one that up to the next person to decide how they want to send it to the internet, or they want to save it on the drive, or do whatever with it. So here this is the main two boards that I'm working with, and let's go to the next part. So this is the ESP32 board. It has lots of pins, and it has a lot of connections, 2 buttons, and 2 these are micro SD ports, but one is for USB and one is for UART, which have different functionalities. I've connected it with a USB to my computer, and that's how I upload the program that I've written to control the sensors. And you've seen the sensors already. And this is the pin mapping for the ESP32S3 model. And here you can see that different pins have different functionality. So the sensors have a particular requirement where they can connect to. And this could be one of the reasons I couldn't get the microphone to work, because it has a particular pin number, and those pins are not in this board, or I'm not sure what the issue is. So here I lay out all of the sensors and their data pins and their voltage power pins, and I've connected them. This is the gateway which I mentioned as per my system architecture. This is going to receive the data from ESP32 board and save it on the SD card. Okay, so here then if I go down, here I talk about the BLE, the Bluetooth low energy technology, and then in the data transmission there are some variables that as a administrator you can change these variables. So these are the two important variables to decide how long before you want to wait before you collect the next reading. For example, if you want to collect the reading every 15 minutes, so you will type in 15 over here, and 10 is a second, so it's 15 minutes and 10 seconds. And if you want to do it every so many hours, you just put in those calculations, and this will be doing a reading after that much time. So as we know that the ESP32 has to send data to the Raspberry Pi, and suppose that ESP32 wants to send the data out, but it cannot find any Raspberry Pi connection. So this timeout, this wait timer will dictate how long the ESP board will wait before retrying for a new connection. And this could be set again to however long you want it to be. Okay, so now here I write some things about data collection, and I think I've covered most of this stuff. Okay, so this is the hardware setup and the software setup. So here the two most important files, I think the two main files which I've developed, one is the Arduino file, and This obviously has the this goes on the ESP32 board. So I've labeled that ESP32. All these files are available in the folders. And the second file goes in the Raspberry Pi, which is a receiver file, I'm calling it, and it's a Python file. I went with Python because it's easier to program in that, and that was a good option to take for that reason. Here are some of the libraries used in the Arduino program. And here again, I have the timers, which I mentioned. And there's also some service ID, which are by default, but these could be changed if you want to change them. There's a more settings parameters. One of them is the broadcast address. And this is the address of the ESP32 board, because when the data goes to the gateway, which is the Raspberry Pi, imagine you have many boards, ESP32s, just sending data. You have 10 of them, and you have one Raspberry Pi. So you need to identify that which reading is coming from where. So this part of the code is inside the files for you to change. And okay, so yeah, so this actually goes on ESP32, and that's because ESP32 will only connect to this MAC address for the Raspberry Pi. So that means if it's not going to connect to a wrong one. So that's another thing. Okay, so then you have this is the pin mapping for the connections for all of these 4 sensors. Okay, and then the data is being collected in this format, and here I explain what it means. So each line is one reading, and I've started with collecting the timestamp, which is taken from Raspberry Pi. I don't know if many people know about this, but it was new for me because I had to learn all of this stuff to program it. The ESP32 does not have RTC system built into it, and what that means, it does not have an internal clock. It does not know what time it is. So when the data is being collected, it is timeless. And for that reason, there were many options how to design this. One was to connect with a BLE to get a time and then do a time stamping. So that was going to require more of the data usage. So I did not go to that route. I went instead that when the data is received, the Raspberry Pi is going to stamp with the incoming time of when the data is being received. This may be inaccurate in terms of data, but I think it doesn't matter that much, because if you're sending data off every 5 hours, then you know it's 5 hours old, or you could work it that way. And this is the MAC address of the ESP32 board, which I was mentioning. So the other one was for Raspberry Pi. This is for the ESP32 board, the 32 board. And then the sensor reading, I have 3 items here, and this is a comma separated values. One is the type of the sensor that's sending the data. Second is the type of the data. First is a sensor type name. So it's a BME sensor. Then it's a T is for temperature, H is for humidity, P is for pressure, G is for gas, and then finally you have the reading for each of the items. And this makes the transmission of the data short, because if I am going to send a whole JSON format, it's going to take more of the transaction and usage and energy cost. So I've created a protocol to send the data in a minimalist characters as possible. And here you can see the lux. L is for light, so this is for the light reading. The PIR is the Pir motion sensor, with for M for motion, and 0 means like there was no motion detected, or 1 for there was motion detected. The lastly is the one is for mic, A for audio, and this was I tried working out to detect how many decibels there is noise in a room. So that was my goal, but at the moment, because it's not picking up sound, so it's coming at 0. And then now moving on, after the file has been received in Raspberry Pi in a CSV format, I have also created another file which is Excel sheet, which actually analyzes the readings. These readings which I did, they were all done today, so they are more or less the same. So it's they're comprised of minimum value, maximum value, and average value. So what, for example, the temperature was, maybe that's we can look at the humidity. So you can see that it's fluctuating, but of course in one day's time it's not going to be that much, but this would be a nice analysis file to use. Moving on, I see we have power consumption, and I've tried to work out my very best what could be the actual cost of running this system overall. And I try to go micro as possible to break down at a very basic level. So I try to calculate what is the power consumption for each of the sensors, and then for 1 hour and for 24 hours. And as you can see that uh, if I'm going to run the sensors, all four of them simultaneously, I'm looking at 13 milliamp hours. I'm not sure if this is entirely correct because this is not my field, the electronics, but this is what I've come up with. And now we know that we are powering the sensors as well as the ESP32 board. And ESP32 board has its own power consumption requirements. And depending on if it's in ideal mode, that means it's not doing anything, it will have a different power consumption. And if it has a BLE mode, then it will have a different power consumption. As I discovered, that BLE server as compared to BLE client has different power requirements. So as we can see that this, if I make the ESP32 board the server, I'm going to save around 100 and something milliamp hour. So this is what I've chosen. I also created MQTT server, but that was causing some problems. So I think that this was chosen in the end, and it also worked finally, because it's better to have something working or something not than not working. Then I decided to do some research into possible battery solutions. And as we know that we have very famous 18650 lithium ion battery, and most of the batteries they come with a 2000 milliamp hours up to around 3000 milliamp hours energy. On eBay you can find a lot of fake lithium batteries that will claim to have a battery of 5000 or even more. I have purchased those batteries as well, but they do not have that much power. In fact, they have around 500 or 700 milliamp hours. They are very light, and to detect if a lithium ion battery is fake or not, you can weigh them, because when you weigh them, it will have the weight to give you an indication how much lithium it has. So I have purchased quite a few lithium ion batteries in the past, and I will show you some of them. So here what I'm working out, if your battery is 2000 milliamp hours, and if you're going to use the reading of the sensors and send the data off every once or 24 hours, and on one battery it's going to last only 5 days for you. Okay, now, and if it's always on, of course it's going to run out in 3 days. And I don't see how anyone can think about running this for 6 months or more, unless my calculations are wrong. I don't see this working very well with a battery. So carrying on with this, then I have some conclusions and some recommendations. Now I will quickly move on to the files that I have for you to show. The two main files, that this one, the Python file goes in the Raspberry Pi, and this one goes into the ESP32 board. I do want to walk through the ESP32 board, and for that I'm going to go remotely on this system. Okay, so here we can see that this is all the code which I was able to put together, and I will just scroll through the whole thing, and it has different functions, you know, like starting the Bluetooth service and checking if it's Bluetooth is on or not. Then there's a loop which turns on the Bluetooth at the set time, which I talked about before. And it has other parts, which this section is for sensors. So I separated the top and the bottom of the Arduino file to keep the code separated as much as possible, because I build them separately, one with working with sensors and one working with Bluetooth, and then at the end I merge them together. And here all the way down you can see how all of the code looks like. So that's the one part. Next, I'm going to walk you through the Python file, and this is the Python file, and this is where it's going to broadcast to. I think I'm thinking about Python. Yeah, this is the ESP32 MAC address, correct. This is the target machine it wants to connect to. And here, this code is not that complicated, and it's fairly simple, but it is smart code. It's very small. And what it does, it produces a file called text0.csv. There's a file size limit which you can modify, which will, you know, if you make it 10, then when this file is at 10 megabyte, it's going to create a text1, and it will keep going. So I thought that was a smart idea, because you don't want to put all your data in one file, and before you know it, it's just gone like X number of GB, and then you end up losing the whole file because it's full. Okay, so on the right side, this is the text0.csv file, what it looks like, and as you can see, I've been running it today, and here these are the readings. Now I want to quickly play the file. So I'm going to come over here and hit play, and now as you can see here, it's receiving the data already. And if I go to the very end, we can see the data coming in. And on the other hand, if I come up over here, we can see, let's make that bigger, and open the serial monitor. So this is the console log for the ESP32 board, and you can see, because I've set the interval to be 15 seconds, is gonna turn itself off and then come back on. And as you can see here, it's sending the data, and here I'm receiving the data. And also they're different boards. They are just, you know, communicating via Bluetooth, and we can see this is live reading. And the lux right now, which is the light, is 5.53. And if I move my light a little bit further to the sensors, now I think this might be a good time to show something on the screen, because I have a second camera set up. And first I want to show some of the parts which I purchased myself. This is a lithium batteries, which I was talking to you about, the 18650. I have 4 of them here, and if I plug this in, this is a charging, a balancing charger for the lithium ion battery system. So this is quite nice to have. With this one, I can check the voltages, how much my battery is doing. And my plan was to actually connect it with the actual battery previously, but now I think there's no need for that, but I have everything ready. Here's other gadgets which I bought, a complete set to make sure that I have all the wires and everything. And I had purchased these, the motion sensor. As we can see, this is my purchase. I bought this one. This is the BME680 and then this is the microphone, and I also have the light sensor. These are all the purchases I did by myself, ready to go. This is my Feather ESP32 board, which I didn't have to use because those were provided to me. I also had another sensor which is quite huge compared to this one, because this was the sensor that was chosen to be used in this project. And here's so this is the microphone. This is a different, this is a B11750 sensor, but so the one I did use that was provided to me are sitting over here. And as you can see, that this is the big ESP32 board. All of the connections are being connected with a breadboard. And this is mine. All these wires are mine. They were not provided to me. And thankfully, I had this stuff from last year, so I was able to use it. And I had everything ready to go. I knew what I had to do, so there was no big issue. And this is the motion detector. This is the humidity and temperature. This is the light sensor, and this is the microphone. And as we can see, I think you are watching on the screen, and I'm going to try switching the light on and off, and you will see how the reading updates on the screen. So here I have a lamp. I'm going to switch it off, and you will see the lux went from 35, 31, 35. So we have to wait 15 seconds because we have to wait until the next frequency comes, which is after 15 seconds of reading. So here we are going to see in few seconds. So let's see. We will see some data coming in. Okay, so now it's reading again, and we can see that the lux light has fallen to 3.69. Previously it was 35.94. And we can also see the motion is 1, because when motion is 1, that means there is motion. 0 means there's no motion. So all of these readings are being done live, and I think it's quite nice work. Next, I want to show the analysis file, which is the outcome of the file that's being saved. I'm going to include one sample text file, which I've done. So if I go into the Python file and I look at the text CSV file, and this is all the file in here. And now I'm going to open the text Excel file, and what you do is you just copy paste all of this, and Excel will is smart enough to separate them by column. And here what I do is that I added a heading, and then all the data is pasted, and here there's a chart. In this chart you can see that you can see your data and you can analyze it. So this is included in the files that I'm going to be adding. So in the files, there are these 1, 2, 3, and I think I also need to include these 2 files. That would be good. All of these folders are included. But the main files, which are final files, because there are a lot of files in, for example, Arduino and Python, which I've worked on, many different files, many different trials. So if I open Python, you will see a lot of tries which I've done, different versions. So it's all included. You can check them out. But these are the final files. For example, this is the final file, and this is the final file, and these are the output data files. This is my report. In Arduino, you will see that there are a whole bunch of different files which I tried, libraries I downloaded, sensor libraries, and so forth. So all of this is there if somebody wants to look at it. I don't think I needed to add anything from last year, other documentation, because all the research, everything that was already provided. So that's all of that has been sent. And this time I'm sending all of my work, and this is all my work, and I hope it should be enough. And finally, I would talk about the limitations and recommendation of this system. I think the system is quite a good idea. You can, once you have the data, you can apply machine learning to that data, and then you can possibly do other things which can help conserve energy overall in your house. And if there are any questions, you're welcome to email me. If I missed out something, you can ask me questions, and I'm sure I can try to answer them. But I'm sure I've forgotten many things or didn't do some things well. But of course, given the time and given the resources, this is what I've done, and I hope this is okay. If there are any questions, please email me, and I will be happy to answer them. Thank you very much.